Okay, this video is going to be about solving this system of equations by graphing it. Okay, so the procedure, remember, looks like this. To solve by graphing, graph each linear equation of the same set of axes. Then the solution is the point of intersection of the two lines. So, that means we're going to solve each of these for y to get it in the slope-intercept form that I'm pointing to here, y equals mx plus b. So I'll write them separately. Two x plus 3y is equal to 0. Solve that for y. And then we'll do this one over here. 4x plus 2y equals 8. And pick out their y-intercepts and then their slopes and graph them as lines. So this one, to solve for y, first we subtract the x term from both sides. Since we have a 0 on the right here, when I add those together, I just get negative 2x. These two on the left will cancel, add to 0, so they don't need to be written. And I simply have 3y on the left. And again, as always, to solve for y, we're going to divide by the 3. And we get this little equation, y equals negative 2/3 x. Now, what is the slope and y-intercept of that? The slope is negative 2/3. And remember the y-intercept, I'll abbreviate that so I don't have to write that whole word, is a point. It has two coordinates. We don't see a number here. So what are those coordinates? Well, remember that it's always x equals 0. And if I put 0 in here for x, this term would turn into 0. So y is also 0. That's the origin, 0, 0. Let's graph that line first. So we know that one point on the line is 0, 0. We'll graph that right there. And then we use this slope to find other points. Remember, it's rise over run, so that's negative 2 and 3, for instance. Rising negative 2 means going down 2. And then running 3 would be this point here. You can also put the negative sign with the 3 instead. At positive 2 over negative 3. That means we'd go up 2 and back positive 3, negative 3 rather. And get a line like that. So we've got 3 points now. It's easy to draw that line. I'm sorry, I'm covering the graph there so I can make it look good. All right, looks like that. So that's one of the lines. Now in a different color, I'm going to do the same thing with this other equation. Subtract the 4x from both sides. And I end up with 2y equals negative 4x. Remember to put the x term first. Plus 8. And then to get y by itself, divide by 2. And y is equal to negative 2x. Negative 4 divided by 2 is negative 2. Plus 4. And let's list its slope and y-intercept. The slope of this one is negative 2. To use the rise over run, we can put that over 1. Again, the negative sign can go on either one. I could write it as 2 over negative 1. And this y-intercept, let's put it down here, is a point, 0, and 4 is the b value. Okay? So now we're going to graph that line. We'll start at 0, 4, which is this point here. Right there, right? That's 0, 4. And the slope is negative 2 over 1. So we go down 2 and over 1. And we can repeat that. Let me get that in the right spot. Down 2 and over 1 again would be here, and down 2 over 1 would be here. If you miss a point, just make it a little bigger. And now we've graphed both lines. Put an arrow on that end too. And we can see their point of intersection. It's this point right here. Okay, that's where both equations would be true if we plugged in this one unique point. And that point is 3, -2. So that's the answer to your question. You solve that system by graph.